Okay, halfway on to question 6 of 10. This one is about electromagnetic induction. So we've got 3 bits of equipment: a bar magnet, a coil of wire, a voltmeter. We're told it's a sensitive one. It's going to have to pick up a very small potential difference. And we need to draw a diagram to show how Pedro would set up apparatus to demonstrate electromagnetic induction. So we're going to induce a current using magnetism. And the idea would be our coil of wire would connect to our voltmeter. And we'll have our coil of wire, so we need a complete circuit. And we would have a magnet. I'm just going to show that we could move that magnet into the coil of wire. And just 1 mark for this question, so that should do us nicely. We might want to just label it just to be sure, but I think we'll be all right with just our diagram and then our voltmeter down here. Okay. So as that was part 2A1. Okay, let's go on to 2. Now we've got a more serious question. This is worth 4 marks. 4 marks up for grabs here. So what do we need to do here? How would Pedro use this apparatus to demonstrate factors affecting size and direction of the induced potential difference? Okay, so if we want to measure the direction, we would, this voltmeter, you may have used these in class where there is a needle and we've got various markings on our voltmeter, and the voltmeter could go this way, or it might be a digital voltmeter. Whatever it is, we're going to see that it's either going to go this way and then this way, or it's going to be positive and then negative. So that's going to demonstrate to us that there is a changing direction in the field. So we're going to move the magnet towards the coil and then away from the coil. And then, so that's going to be for a mark, and then we're going to note, or we're going to see if there is a change in direction on the meter. So that would show us as we move it towards, maybe it's positive and we move away and it's negative, or it could be the other way around. We move it towards and the dial goes one way and then goes back the other way. Okay, let's work on my handwriting for this next one because that was pretty atrocious. All right, so the size, perhaps I should have done that in the right order. There we go, there's direction. So let's move on to the size of the magnetic field. Now, what we're told is that we need to demonstrate the size with this particular setup. So you might know that if you use a stronger magnet, then you'd get a bigger induced potential difference, but we're told with this equipment, so we can't change the magnet. What we've got to do is do something with the magnet to get a bigger potential difference, and what you might know is that has something to do with how fast it moves. So move the magnet at different speeds. For the first mark there, see how this affects the meter reading. And just to be sure, faster movement gives bigger reading. Okay, so we've got 4 marks here. We've moved the magnet towards and away from the coil to see if there's a change in direction on the meter. 2 marks there. Then we're moving the magnet at different speeds and we're showing that that's having an effect on the size of the induced current. All right, so there's our 4 marks. On to question 6B. Have we got space to do it here? Might as well go on to the next page. We've got 2 parts to do anyway. So 6BI. So in a transformer, you might have seen your transformers drawn a bit like this, an iron core with a coil on the other side, got our primary coil. So our primary coil, need to work on my handwriting today, don't I? Secondary coil. And so if we have a changing magnetic field in the core, so this is the core, describe the cause of the changing magnetic field. So why is there a changing magnetic field in the core? And that's because we're going to put an AC current, an alternating current, into the primary coil. That's going to create a changing magnetic field in the core. So this is a 2-mark question. There will be describe the cause of the changing magnetic field in the core, and alternating current in the primary coil, and that's going to be our 2 marks. I'm just going to make that a complete sentence. An alternating current in the primary coil causes a changing magnetic field in the core. There we go. So not an easy question that, but if you remember what a transformer is and you go through the steps, and that should help you. Okay, and then we've got an equation. Regardless of what you're doing this equation will be given to you. All right, it is the equation for number of turns on the coil and the potential difference that we get. So the voltage in the primary coil divided by the voltage in the secondary coil is equal to the number of turns on the primary coil. Number of turns on the primary coil divided by the number of turns on the secondary coil. So as always, what I would encourage you to do is write down any information that we have down the side, and all the factors that we're either got or that we're looking for. So we're told that there is a potential difference of 230 across the primary coil. So 230 volts here. We are told that there is a potential difference of 15 across the secondary coil. And we're told that the primary coil has 2,000 turns. All right, so what we need to do is, this is what we're looking for, the number of turns on the secondary coil. So we need to rearrange that. So what I want to do, again, I'm not going to go deep into rearranging now. We can do that in a different video. I'm going to move the number of the turns in the secondary coil up to the top there, and that's going to give me this equation. Okay, so I put that up the top, I brought this down there, and that's gone up there. So the number of turns in the secondary coil is equal to the number of turns in the primary coil multiplied by the voltage in the secondary coil, all divided by the voltage in the primary coil. So let's substitute into that. We've got our 2,000. Say this just makes it really easy. We're not going to make a mistake now, because we're just going to copy in the numbers that we put down the side. 230, and then we're going to get a calculator, and we're going to put that all in. 2,000 times 15 divided by 230, and that's going to give us 130. 130.4, but again we're going to go with, we only need to give 2 significant figures. I'm going to stick with doing 130 turns, and that is our answer. 130 turns, and that is the next 10 marks done and question 6 done. Thank you. Join me for the next one.